So yesterday in the video I gave you this function f of x, and I showed you in class today that the derivative using the product rule, first times the derivative of the second plus second times the derivative of the first, and there's no need to simplify that at all. Today I'm going to teach you about the quotient rule. So in a quotient rule, you're going to have two functions divided by each other. So you'll have some function f of x divided by some other function g of x. And if I wanted to find the derivative of that, what we're going to do is we're going to take the derivative of the top and multiply it by the bottom. So the notation would be the derivative of f of x over g of x with respect to x. So the derivative of the top, we call that f prime of x, multiplied by just the bottom. So the derivative of the top times the bottom. Now you subtract from that the opposite, which is just plain old f of x times g prime of x. And that all gets divided by g of x squared. And so I'll just go through a few examples of this. This is a little bit more complicated than any other rule that we've seen. So we'll just go through some examples. Let's say we have f of x is equal to x plus 3 over x minus 7. There's no way to simplify that down, so we can just use, what we could do is we could call x minus 7, we could pull it up to the numerator and call it x minus 7 to the negative first power, and then use the product rule on that. But I think it might be easier to use the quotient rule. So f prime of x is equal to the derivative of the top, which is just 1, times the bottom, x minus 7. Subtract from that the top function x plus 3 times the derivative of the bottom. Well, the derivative of x minus 7 is just 1, all over the bottom squared, x minus 7 squared. So this becomes x minus 7 minus x minus 3, because you have to distribute that minus. So x minus 7 minus x minus 3 all over x minus 7 squared. And when you combine like terms, the x's cancel out, and you get negative 10 over x minus 7 squared. So that's in simplest form. Here's another example. Let's say we have f of x equals, let's say, x squared plus 2x all over x minus 9. This can't be simplified at all. You could factor out an x in the top, but that's not going to do you any good. Again, you can bring the x minus 9 up to the top and call it x minus 9 to the negative 1. But let's use the quotient rule. The quotient rule says take the derivative of the top, which is 2x plus 2, and multiply it by the bottom. Subtract from that. Now we're going to take the whole top, x squared plus 2x, and multiply it by the derivative of the bottom, which is just 1. So I'll just keep it like that, all over the bottom squared. Usually we'll clean this up a little bit, because every once in a while we'll be able to cancel something out, or maybe make it simpler if we want to find maybe f prime of 4 or f prime of 7. So what I'm going to do here is I'm going to FOIL this and subtract out the x squared and the 2x. So when you FOIL this out, you get 2x squared minus 18 plus 2 is minus 16x minus 18. That would be the top FOILed, this part FOILed, and then you're subtracting out an x squared, subtracting out a 2x, because you distribute the subtraction, all over x minus 9 squared. So if we clean this up, 2x squared minus x squared will just give us 1x squared. Negative 16x minus 2x gives us a minus 18x, and then minus 18. So it looks like, I don't think this is factorable at all. If you could factor, like maybe if you could factor this into x minus 9 times something else, you would be able to cancel that out. But that's about all you can do with this function. So x squared minus 18x minus 18 all over x minus 9 squared. You'd write that in a little bit cleaner fashion. So that's all the product rule is. Remember, derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. I'm going to teach you about trig derivatives now, or we'll get a lot of practice with this tomorrow. So trig functions, we're going to take derivatives of this. So let's look at sine of x. Y is equal to the sine of x. And let's just look at a beautiful graph of y equals sine of x, pi over 2, pi, 3 pi over 2, and 2 pi. Haven't done this in a while. So it goes up to 1, and it goes down to negative 1, and it goes through the x-axis at pi. Well, here's pi over 2, goes through the x-axis at pi, and here's 3 pi over 2, and here's 2 pi. So that's just y equals sine of x. What I'm going to do is right underneath it, I'm going to plot the slope of sine of x. And I'm going to use the same scale. So we got 2 pi, we've got pi here, and we're going to go up to 1 and down to negative 1. So this is down here, this is going to be the slope of the sine of x. So the slope of this graph up here, which is actually going to be the derivative of the sine of x. So when we start here at x equals 0, the slope of this function right here at x equals 0 is actually 1. It's been calculated to be 1. So this slope is equal to 1. When you get over here at pi over 2, you know that this function maxes out here, and the tangent to this graph would be horizontal, so this slope would be equal to 0. So the slope here is 0. Now we're going to go over here to x equals pi, and this slope here has actually been calculated to be negative 1. So at pi, the slope of the sine graph is negative 1. Down here at 3 pi over 2, this is a place where it bottoms out, so this tangent line to this curve would have a slope of 0. So we're going to plot that here. And then back here at 2 pi, the slope is equal to 1. So here's a positive 1 up here. And now if you connect these points with a nice smooth curve, hopefully you've noticed that we get the cosine graph. Y equals cosine of x. Here's y equals the sine of x. And it all has to do with what is the slope of the sine curve at each individual point. So if you're given y equals sine of x, the derivative is equal to the cosine of x. That's pretty important. Now let's find the derivative of the cosine. Let's be given y equals cosine of x, and let's plot that. 1, 2, 3, 4, 2 pi, and pi goes up to 1, down to negative 1. Too high. All right, here's y equals cosine of x. Now underneath, let's graph the slope of the cosine curve from up here. Well, we'll have to mark our x-axis exactly like we did above. So here's 2 pi, pi. Let's go up to 1 and down to negative 1. So right here, this slope is equal to 0 because it tops out and starts heading down. This slope here at x equals pi over 2, this slope is equal to -1. The slope of the cosine curve at x equals pi is equal to 0. The slope at this point is equal to +1. And the slope here where it tops out is equal to 0. If we connect this with a nice smooth curve, I haven't really drawn a sine curve, but what I've drawn, the slope of the cosine curve is equal to the negative sine of x, because this is just the sine curve that's been reflected in the x-axis. So if you're given y equals cosine of x, the derivative of the cosine of x is equal to the negative sine of x. So here's something else that you need to memorize. Let's do a tangent. Y equals tangent of x. Well, we're going to approach tangents derivatives a little bit differently. It doesn't come out as nicely as sine and cosine do. What tangent is really equal to, if you remember, it's sine over cosine. And now we're going to use the quotient rule that we just learned, because we know the derivative of the sine and the cosine. So the quotient rule says y prime is equal to the derivative of the top, which is cosine of x, times the bottom, which is cosine of x. Oops. Cosine times cosine minus the top function, which is sine of x, times the derivative of cosine of x. Well, the derivative of cosine is equal to negative sine of x. All divided by the bottom squared, cosine squared x. Cosine times cosine is cosine squared. Sine times sine is sine squared. And negative times negative is positive. So what we have here is the cosine squared of x plus the sine squared of x all over the cosine squared of x. And we can simplify this in a few different ways, but the best way is, if you remember, cosine squared plus sine squared is always equal to 1. What we have is 1 over cosine squared. Well, since 1 over cosine is secant, the derivative of the tangent is equal to the secant squared of x. So here is something else that you need to memorize. And you don't really have to memorize it. If you want to go through the quotient rule every time, you can. It'll take you a little while. Most people choose to just memorize that the derivative of the tangent is equal to the secant squared. So those are the three main derivatives, sine, cosine, and tangent. And we can get the other three in a similar way. We can do the quotient rule on all three of them, but I'll save you some time so you don't have to listen to me talk about this. The derivative, if y is equal to, let's say, the cotangent of x, well, the cotangent is cosine over sine, and you could use the quotient rule in the same way and figure all this out. But the derivative of the cotangent is actually negative, and since the tangent's derivative is secant, the cotangent's derivative is the cosecant squared of x. So there's your fourth trig derivative that you need. The next one is y is equal to, let's say we just are given the secant of x. Secant is 1 over cosine. So we could go through the quotient rule and figure out the derivative using the quotient rule, and I welcome you to do that if you'd like to. But in the end, you'll see that the derivative is equal to the secant of x times the tangent of x. And then we have one more, which is the cosecant. So if you are given y is equal to the cosecant of x, what is its derivative? Well, cosecant is 1 over sine. You could use the quotient rule if you wanted to and figure this all out. Or you could just, if you can remember that the secant's derivative is secant times tangent, The cosecant's derivative is negative. Any trig function that starts with a c has a negative derivative. That's just a trick to remember this. It's negative CSC of x, COT, cotangent of x. So the secant and the cosecant's derivatives are very similar. The only difference is you start with a co on these, and these are just secant and cosecant. So I think I'm about out of time, and we'll practice this tomorrow.